All right, so this is problem 4b, and we're going to try to prove that e is an irrational number. And we're going to do a proof by contradiction. So if you remember back to the beginning of last semester, we proved that certain things were irrational, and this is going to be somewhat of a similar method to do that. It ends up getting to be a bit different down below, but we'll start out the same. So first, we're going to assume that there exists p and q elements of the natural numbers such that e equals p over q, right? And from 4a, we know that that means that e minus sq is in between 0 and 1 over q factorial times q, right? And then a little bit of algebra helps us. We'll multiply by q factorial, right? And we'll simplify it down. So what we want to do is we want to show that these two terms here are integers, right? So the first thing we'll do is show that q factorial times e is an integer, right? And we see that q factorial times p over q is equal to p times q minus 1 factorial, right? And an integer times an integer is an integer, so therefore this first term up here is an integer, right? Now we want to show that q factorial times sq is an integer. So we can represent sq as 1 over 0 factorial plus 1 over 1 factorial, 1 over 2 factorial, all the way up to 1 over q factorial, right? And if we distribute this q factorial, it contains all the factors of the denominators. So each one of these denominators is going to cancel. So we're basically going to be adding a bunch of integers together, right? So therefore we know that q factorial times sq is also an integer. All right, and then from line 3, we're just going to rewrite what we had up above. Really what we're trying to show is that q factorial times e minus sq is less than 1 over q. Now, we remember that q is an integer. Is a natural number. So the smallest number that q could be is 1, and 1 divided by 1 is 1. And as we get larger, as q becomes larger, this fraction actually is less than 1. So the largest that this fraction could be would be 1. So 1 over q is less than or equal to 1. And since we already showed that what is in the middle of the inequality is an integer, and it's less than the number 1, we have our contradiction. And therefore, we can say that e has to be an irrational number.